Welcome to the stream, everybody. The stream has started. Hello, it's the stream is now. Okay, I gotta check. Am I live? Can I hear myself? Hello, can I hear me? Okay, I can hear myself. We're good. We are good. We're live. We are live. It is working. Let us make an announcement. Look at this awesome Eternal Wild Fox, by the way. Getting work done as usual, like at breakneck speeds. He converted to going directly from tokens to using an AST, and then from the AST, he's generating bytecode from it already. It's pretty legendary. And he's got if and while already implemented and all working, which is so cool. It's very cool. Now let's make our announcement. I get distracted in the Discord. It's so much fun having all of you here. Compiler. Part 28. Also, you guys are spoiled. You got 4 days in a row that I've streamed every morning. This is incredible for me. This is like the most schedule I've ever been on. All right, we are officially live. Woo woo. We did it. Welcome everybody. Welcome, welcome. I'd say that we should just get right into it. Streamer 2022 fun compiler. First time chat from a new viewer, Dino Casho says, woo! Woo! It's like Ric Flair up in here. Dino Casho, how's it going? Thank you for tuning in. What's up? What's up? That's right. Today we're going to be working on our compiler, which you know if you saw the announcement. And we have a lot to do. We have a lot to do. As you can see by this incredible to-do file that is already almost 2,000 lines. And only 800 of those are done. So we have 1,200 lines to do. I guess there's some to done here, but there's only like 80. Okay, 1,100 lines to do. Not bad, not bad. And each of these are expandable. Okay. So let's think about, first of all, the README. There's an issue in the README, and that is in the language reference. And it says a lot of stuff about the language, just some ideas that, hey, this is now true. Whee! That's fun. But this is no longer how functions are defined. So this used to be our factorial example. And now our here, let me load the proper editor. Also, I did some research on Vim. I want to talk about that so that YouTube doesn't destroy me and tell me I know nothing about Vim. Because I do know nothing about Vim, but apparently you're not allowed to not know things. So basically, yesterday, we went through and copied a, not copied, but used as an example, the Yacht Vim syntax highlighting. And we wrote some Vim script in Emacs, which is cursed, right? And the thing is, this is not how, you can't just have one part of a Vim plugin, sadly. Vim don't work like that. And Vim plugins have a whole folder structure, which is annoying to have to deal with in the file system, right? But that's how they are. So now when we look here, I did a bunch of research. I found this article. Let's see if it opens in the right spot. It didn't. We can try. Okay, we're gonna try. Okay, it opened in the right spot. We did it. Chat, we did it. But this article, here, I'll paste it in chat right now, in case you want to read it. This is for Vim syntax plugins, and it's actually really nice and has examples and is slightly understandable. And it tells you all the commands in Vim that you can use to get help with this stuff, which is awesome. But yeah, so this was very helpful, and that will be something we need to fix, because we wrote the syntax part, which is somewhere here. We wrote the syntax part. We wrote this file. We didn't finish it. We wrote part of this file, and then we didn't do anything else. So we're getting there, but we need to create a whole structure for Vim, which means we also need to organize our editors folder, which again, all of this is fine. So we can load our Emacs custom editor mode. Perfect, perfect. Okay. And what do we get? So here we have our language, and this is our new factorial example. And it's actually here. Let's just close some things that I no longer need. Okay. As you can see, this is different. Okay, thank you. That was a large gap. I was like, oh, Emacs. Hello? So as you can see, we used to have defun, which would define a function. But now to define a function, you just have the type of a variable declaration set to a function signature, which is it returns an integer and has one integer argument. Parameter, I should say. And then you just assign it to a lambda, which has a function signature and a body. Pretty cool. Lico13 says, yo, how's it going, Lico? What's up? What is up? Lico says, gotta love lambdas. You do, you do. We got them lambdas, baby. But yeah, so now functions are treated as variable declarations. I think if we do this, it'll even do that. That's pretty good. And no longer are they like their own thing that have their own syntax and everything. They're just variables that have expressions that can be assigned to them, which is lambdas. Woohoo! Factorial of 5 is 120. It's not 24. I think we had factorial of 4 in there before. But yeah, this is all cool. And I think that's plenty. I think that's everything we need to know. Yeah, that's good enough for me. Alright, let's just make that get the commit and fix up our readme, and then we can get started writing some code for the day. So basically, yes, yes, yes. So these three, we are going to commit the commit. Lico says, will type inference happen anytime soon? What kind of type inference? Like variable declaration type inference or just type inference? Perfect. We commit the and we push it. Yeah, like declaring fact function, for example. Yeah, we're gonna have, so for functions, we're gonna have a custom syntax. We've talked about this many a time, where this is gonna be gone. So you're just gonna be able to have a lambda as the type of a variable, and that will mean that this is a strong function. Negvorsa says, hello. How's it going, Negvorsa? It's so good to see you. Thank you for tuning in. We are working on our compiler. But we're going to have something like this for functions. We're not going to have type inference for functions. Like, we're not going to infer what type the return type is. We may eventually, but it's not in my mind right now. But for like integers and stuff, it's definitely gonna, I think we're gonna have something like an automatic, like the auto keyword in C++. You know how in C++ you can do like auto int a, not auto int a, auto a equals 8, and it'll be like an int or whatever. We want to have like an a reassignment like this. I don't know what it's gonna look like, maybe that. I don't know. It's gonna be some other syntax, and That'd be weird. That'd be really confusing if we just did the opposite of the reassignment. But yeah, we're basically just gonna have the type be able to be inferred and make sure it's a constant. I mean, it doesn't have to be a constant, but we're gonna have stuff like that so that you can't like infer the type of, I don't know, some random expression. We'll see. But yeah, we're definitely gonna have some syntax for type inference. It's just not gonna be it's not in my head because this is a statically typed language, which means Lico says fact equals lambda definition. Oh, I know. Yeah. That's what we were just talking about with the integers. Like, oh, a could be an integer. We could also have it be a lambda definition allowed here. But I think this would allow for, I don't know. It'd be fine, I guess. It doesn't really matter. But then that means that a isn't statically typed, really. I mean, it is going to be statically typed. It's just going to be not explicitly type annotated, which is kind of scary to me in a statically typed language. Some language has a keyword infer. Yeah, we're not into keywords in this language, if you noticed. We're very heavy on operators, and we're very light on keywords. Because if you look at my past language, if you look at Korth, it's only keywords. So I've definitely deviated from the keyword feeling. Like, maybe less keywords, because everything in that language was a keyword. Lamau. Korth was done very badly. I could do better now. But yeah, Lico, you're absolutely right. We could allow for something like this. It just scares me. I guess it's fine. But yeah, type inference we already have done. So like, in case you're interested in the actual like how it works, in the type checker, every time we type check an expression, you can see that we actually get its result type. So every expression that we type check, we infer its type. If that makes sense. So when we type check, for example, an integer, you can see that the result type is actually set to the integer type. Right here. Does that make sense? So every time you type check an expression, you both ensure that it has proper types. Like a variable access must be a valid variable, and address of must have a variable access as a child, right? And then you say, okay, and the result type is going to be the child expression, this variable access. And the reason we do that is so that we can type check the variable access, make sure it's all good and it's all clear. And then we can just go straight to setting the result type. So all we'd have to do for type inference is in a variable declaration, right? We would have to have some binding, some parameter type that we can get. Is that right? No, that's not right. That's the wrong spot. Do we not? Seriously? Is it not handled? That'd be terrible if we just don't handle variable declarations. Just not setting the result type. Maybe not. LanderXT says L to the E to the N to the O. Ooh, L to the E to the N to the S to the underscore to the R. Ooh, I forget my Twitch name sometimes. I almost said Lenor. How's it going, Landar? You're here. You're once again at the stream. What's up, Landar XT? Thank you for tuning in. It's so good to see you. Have you back. Snarlferb recommends A/?1. So type inferred variable declaration. So, oh god. Oh. I don't like this. And it's not just because I don't like it. There's reasons. One, what is that? That's the division operator. Lamau. And then what is that? What is that? Snarlferb says that's so funny. We try and have operators only do one thing. That's why we removed, like, pointers aren't star. So you don't say, like, a pointer to an integer like that. You say an at integer. That's a pointer. So it seems like we should have either a custom symbol for this, like caret, or we adapt the type area to actually have, like, none as a type. And then just say that can be inferred. You know what I mean? And then we would have to have some syntax that would do this. So we could have, like, that, right? Is what we're thinking about. I think that's not bad. I know that's the less than operator. I don't really like that. If I had another another key, I would do it. But there's no other button that really makes sense. LanderXT says, I could have been here to the start, but I couldn't be bothered. Ooh, my feelings. My feelings are in the trash now. No, I'm kidding. We could also have what? There's the hash. There's the bang. We could do like a bang. That's not bad. This doesn't do anything else in the language. I guess we could also do the question mark. The question mark isn't bad. I don't know. Not bad. LanderXT says, nothing against you, lol. I didn't even want to get out of bed at 4:30 p.m. Oof. It's okay, Lander. I'm glad you finally did. And if you're still in bed, I'm glad you chose to, you know, actually do something. Sometimes it's really hard. I understand. Liko says, I think the strategy you mentioned is inside-out type checking, but there's also bidirectional type checking for more complicated type systems like in theorem provers, or like in Haskell doing Hindley-Milner type inference. I haven't implemented it myself, though. You're probably right that the strategy I would do is inside-out type checking. I don't know anything about type checking, and it's like impossible to find understandable content on how to learn type checking in systems and type systems, so this is just what I came up with. This is literally off the top of the brain, so it sounds like inside-out type checking, because we type check all the way down into the furthest child node, and then that returns a base type, hopefully, right? Like we get, oh, that's an integer, or that's a variable access, and then we can go, okay, we get it now. So default is break, which will take us to just returning error. Okay, so default, nothing happens. So are there any default expressions? I'm just curious. Also, let's set up our build. Let's get our our compiler actually running, huh? So we'll build with CMake. We'll clean first so that we rebuild the entire compiler every time. We will run the generated executable in verbose mode, and we will feed it some example. We'll feed it like the factorial example, for example. And then that should be good. We just have to do that from the proper place. The proper working directory, because we're running shell commands. Look at us. Now we have an AST generated. As you can see, it's a variable declaration of fact, and it's a reassignment of fact to a function, which returns an integer, takes in takes in a parameter called n, which is an integer. I know it's not stored here, but it does, I promise. We have an if n is less than 2, then 1, otherwise multiply n by the function call of factorial of n minus 1. So as you can see, this will recurse all the way until our recurse limit, which actually Richard Stallman put out a new C manual. He talks about recurse limits and recursion in a really cool way that's very understandable. Snarlferb says, I really am not sure. Ooh, it's true. It's well, the syntax is hard. The syntax is hard. We'll bike shed about it for a few weeks, I'm sure. LanderXT says, GNU General Public License, version 3, 29th of June, 2007. Copyright, 2007 Free Software Foundation Incorporated. Everyone is permitted to copy and distribute verbatim copies of this license document, but changing it is not allowed. Preamble, the GNU General Public License, is a free copyleft license for software and other kinds of works. Did you copy pasta me? Lamau. No, that's just like a general... Isn't that from the Free Software Foundation page? Lander XT says, yes. Oof. Copy pasted. Eternal Wild Fox says, hello, Lens, implementing the bytecode runtime. That's awesome. So if you don't know, Eternal Wild Fox is working on a bytecode generator based on this input language. And the bytecode he's generating, he's now writing an interpreter, apparently, a runtime. That's very cool. Very good. Very, very cool. If it's open source, we would love to get a link to that. Link. Okay, so effectively, we are here twice. That's not good. So I don't think we're type checking variable declarations at all. Is that true? So we're just pretending that variable declarations are statements. This is going to be a developer warning. Unhandled expression type in type check expression. Perfect. Oh god. Liko says, in before MIT license copy pasta. Oh no. Liko, you challenged Lander. He's gonna... Oh, yep. There it is. There it is. Sag. Monka is. Sag. Oh. Lander XT says, I'm curing cancer in VB.net. Lamau. Oh. We'll do something like that. None. So none isn't handled. Yep. We don't need to type check none. And that's already what our result type should be set to, because it's a freely allocated node? No. It's our result type. It's something. So let's just print our result type to make sure we're not breaking things. It's none. We're good. We good. So I feel like variable declaration is kind of sneaking in here. We'll just have it up at the top with none, where nothing is done. Because currently we don't want a variable declaration to return a type. That's kind of not cool. Because it's a statement. Currently this is our one statement, is a variable declaration. Everything else, expression. Liko says, it's funny how MIT started screaming in the second half with all caps. I know, it's like, I get it. The software is provided as is. Okay, you don't have to scream it. Jeez. Lander XT says, I might actually make a super complex program in VB.net just to make that my most used lang on GitHub. Lamau. You are a memer. Through and through, buddy. Okay. I think that's pretty good. Looking better, at least. Okay. So... yeah. We'll just put in some ideas we had. Also, what did we have? TTV at... who was it? It was Snarlfurb, right? Yeah, Snarlfurb. I'm gonna scroll up. Okay. Yeah. No, I'm just gonna do this. Oh, I can't do that. Never mind. We had this. We'll figure out which one eventually we pick. the problem with equals is that this is our equality assignment operator. So like 1 equals 1 is this is true. You know what I mean? And this would be false. So that's our equals equals. Because equals is that. I guess we could have equals equals. Kinda, I don't like it, but it's doable. Or colon colon. Liko says, Liko, you're not from round here, are you? Take a look at any example, and you will see that, in fact, that is how variable reassignments work. Snarlfurb says colon colon I kind of like. Okay. 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 This one may not be too bad. Liko says, oh damn, my bad. It's all good. But yeah, like in math, it's the assignment operator. So when you assign pointer to the address of A, that's like saying pointer is a new name for the address of A. And that's exactly what we're doing here. So it's an assignment. Whereas a declaration, we split the assignment operator, see the colon and the equals, get split into having a type in between them. You could totally have them like this, where you put the type as like touching. It kind of hurts my brain a little, but it's totally doable. Colon colon is like type annotating in Haskell. Nice. It's true, and it also reminds me of if we wrote it like this, it reminds me of like Common Lisp. What are they called? Property tags? Common Lisp property tags they all start with a colon. Okay, so this one may not be too bad. It's like type annotating in Haskell. So that's perfect. Haskell always does it the opposite. Bunch of mathematicians making a language, pretending they know computer science. No, they do know computer science, just better than everybody else, because they're mathematicians. So everybody else is like, this is confusing, what? And they're like, no, see, I can prove it, I'll use cock. And they're like, you guys are weird, I'm getting out of here. An average mathematician and a programmer conversation right there. Hey, we have stuff to do. Lando XT says, eat fruit. It gives beauty and health. The train was going fast. It was going fast. What the hell was the matter with it? And it was going that fast. Is that from my bot? That's terrible. Liko says, the mathematician's program is like, yes, it runs, but it will halt in a week. Also, it's in Python. Lamau. Lander says, no. What is it from? It's very random. That's from the paper I linked. Oh, you linked a paper. I missed it. I'm sorry, I missed it. It's a 14 megabyte PDF document. I'm not going to download that, my guy. What do you... What is 14 million bytes worth to me? What paper is it? It won't even show me the title. It's just a download link. It's a 374 page thesis. Oh my god. Why? I'm laughing too hard to look at my screen. Let's do this. Let's do this. Yeah, why not? We'll move that up there. We're gonna do it. Chat. We're doing it. Okay, so in the parser, it looks like we pass a lot of things around all of these different things, and we may be able to consolidate a little bit at least. So we're just going to create a new, yeah, why not? We'll just create a new struct, and it's going to be a parsing state. Whoops, not parsing, parsing. And I'm going to need this. And this parsing state is going to take over is if we look at all of our parsing, we can see that often we end up with these, many, in fact, of our functions end up modifying a token pointer, a length pointer for the token length, and an end pointer. So all we really have to do is take these three things and put them in here, remove the commas and put semicolons, and look at us. We have our fancy schmancy parsing state. LanderXT says, on Greek linguistics, linguistic study of methods of representation of speech and thought in selected modern Greek literary texts by Mersini Karagivorakis. What? Oh man. That was a mouthful. Basically, it's a language study. Why? What is your life, Landar? What do you do? Are you okay? Is everything okay? I just want to make sure. So now we can say this is a parsing state. And we'll have it just be a pointer and say state. And now look at all this. We can have fanciful... I guess we don't need a pointer because the state actually just contains pointers. But we do need a pointer because we need to alter it. Did you hear that? So we're going to do state. This is I'm editing a lot of things at once. This is pretty dope. That worked great. Whoops. There we go. I love that undo works with multiple cursors in Emacs. It's so handy. Sometimes it gets a little confused, but most of the time it's fine. See, in parse type, we're just going to pass state. Look at us. If this doesn't help anything, we just won't do it. But I'm pretty sure this is going to help things. We can even have it on one line now. It's acceptable. This is an incorrect comment. So you know what we do with incorrect comments. We just get rid of them. Context, state, and type. That's looking good to me. Good enough. Okay, so parse type. Why are you mad? Because we call you here. So now we need to create the initial state in parse expression. Right? So we create the parsing stack, our expected return value, stuff like this. And then we should create our parsing state and say state. And we should ideally like mem set it to 0. I still don't get why variables aren't assigned to 0 by default in C. I understand it's like an efficiency thing, but why can't it just be by default? And you say if it equals, you know what I mean? Like you just say it doesn't equal, and then you're done. I don't know. LanderXT says, I found it by googling ttv.landerxt smells. Lol. LanderXT says efficiency, like you said. It's a negligible amount. How often are there uninitialized variables that shouldn't be zeroed? I'm curious. You know what I mean? What are the numbers on that? So state.current is not actually a token, it's a pointer to a token, so we're still going to need our current token. Which is that's fine. And then we can say state.current equals current token. The address of it. Look at us. We'll start with error equals okay. We'll create expected, we'll create a stack, we'll create a state, we'll create a token length that we can point to on the stack. So maybe I create the state down here. Maybe I don't need to memset it if I set everything right away. I feel like I should have to do address of end, but I never have to change the address of end because end is already a double pointer. So by changing this, I can change the pointer it points to. Yeah, that makes sense. All right, now we just have to use that. And the cool part is we technically don't have to use the parsing state everywhere in this code because guess what? We just use pointers to things that already exist and that we use already. Beautiful stuff. Okay, so what we would like to do is effectively take a look at Lex Advance. Yep, lots of uses. And I think that this is perfectly encapsulated by the parsing state. If not state, or not state current, or not state. Lender says, try this paper. Oh God. You scare me. I think we should make sure end isn't a null pointer and doesn't point to a null pointer. I think it can point to a null pointer. Let's make sure we don't have a null pointer. So now we can just do state.current. State current. Is that right? Yeah, we had token.end. So it'll be state current, and then this is token, so this will be state current. This is state end, changing to state current end. And then what? Token length. State length is equal to state current end, state current beginning. Okay, there we go. Snarlferb says, one of my first introductions into coding was when I downloaded this project off GitHub and one of the subfolders randomly had 800 ebooks in it. Oh no. I thought it was some elaborate riddle I had to solve to understand the code. Now, that's insane. 800 ebooks. So we have Lex Advance. It's not here, so we're just calling it wrong. Yeah. So now you can see we have a token pointer, a length pointer, and an end pointer for Lex Expect. So Lex Expect can now have parsing state instead, which also greatly simplifies everything. Okay. So if not expected, or not state, or not state current, or not state length, or not state end, current copy, length copy, perfect. And this is all going to be state. Look at this. It's slowly making more and more sense. But we have to create another parsing state, which is a copy, which equals yeah, we're gonna have to do like this. dot current dot end equals end copy, and state copy dot, what's the other one? Length equals length copy. And addresses of all of those, please. And then align on something like that. Perfect. Look at us. How beautiful. So now we use this state copy. Why are you so mad? Oh, it's end value. Because I just saved end value. I didn't copy end. That's right. I did the same thing with length. I should just say length value if I'm going to do that. Or end copy. See what I mean? I should just be consistent. It doesn't make sense. And then we can use the state copy here. And then we can say, hey, if we found what we needed, right? If we expected, so if our current token is actually what we expected after lexing, then update state to our state copy. And this should all happen. We could also write this as a mem copy, a literal mem copy, but that is what will be done under the hood. RPWH says, yeehaw! How's it going, RPWH? It's so good to see you. Thank you for tuning in. I feel like I haven't got much done today, but we have had a ton of fun. So you haven't missed much, but it is great to see you nonetheless. How's it going, RPWH? If you don't know, our wonderful viewers, RPWH is our most recent contributor, so we appreciate him very, very much. RPWH says, I'm doing good, thanks. Lander says, isn't that every stream? Yes. We do just mainly do nothing and sit around and talk. But guess what? We have a compiler. So at least something happened in the meantime, right? Something did happen. Okay, hopefully everything works and isn't broken. Hey, look, everything's broken. Because now we get to change this to just being state. And we can say, oh yeah, by the way, let's expect takes in a state. So good. And effectively, we would like to say what? So whenever we expect, we're going to have to change it and go through and use the state. Hey, look, another place where we can have the state in handle stack operator. Parsing state. I'm also going to put it higher up. I don't know why it's there. We'll do context stack and then state. State, context, and then stack. I don't know. I know it doesn't matter. Let's put it here. Why not? That looks right. I guess this would be alphabetical, so we're just going to go with alphabetical since we can. Lander XT says, did you accidentally pirate an entire library, Lamau? For the 800 ebooks. RPWH says, going to figure out how to set up some microcontrollers. Ooh, that sounds fun. That sounds fun. I love embedded programming, like working with real hardware. Lander XT says, that's why it's taken roughly 84 hours to get the compiler into this state. Listen, if you want to make a compiler in less than 84 hours, that isn't just a copy of this code or somebody else's code that you write from scratch, and only during a live stream while people are constantly chatting at you, then I'll take it. I'll admit, maybe I could have done better. But I'd say this is actually pretty good for the circumstances. We've made a lot of progress. We've solved the downwards function argument problem. We're not, like, completely inept, I hope. Lander XT says, I will. The Landar++ language. It's gonna be like fun compiler, but with classes. So good. You're so much fun, Lander. Fun compiler plus plus. No! So good. Sweet. Expect state. Nice and calm. I could probably do like search and replace, but I kind of like doing this. It's going through. It feels like data entry. It's simple enough. I think I just found a new target. Parse binary infix operator can definitely take state. Print token state current. Hey, look, parse base type. This is actually going to be quite helpful, I'd say. Also, we're going to make ourselves a little helper. And then we're just going to say, give us a token pointer. Give us a token length. And then give us a char pointer for the end. And we'll just say parsing state, blah, blah, blah. Parsing state. We'll say parsing state out. Well, no, this will just be return parse state create. With the proper everything. Create. Thank you. State dot current. State dot length. State dot end. That's a pointer. Out dot length equals token length. Excuse me. Why is it? It was all capitalized for some reason. Look at us. Lico says, hey, couldn't A equals 1 still be assignment if A is unbound? But it'll require major changes to the AST, I assume? No. Yeah, that's pretty doable. I see what you're saying. So in parsing, so in parsing, I think what you're talking about is somewhere here. Basically, if we have a invalid variable name as a symbol, then it must be something else. So we check if it's a declaration here. So you're saying like here, literally exactly here, we check, okay, the variable has not been defined before, and it's trying to redeclare or reassign an invalid variable. See, reassignment of undeclared variable is not allowed. So basically, we look for the colon, we look for the equals, and if we have a colon equals after an unrecognized variable name, we have this specific control flow happen. But instead of returning an error, we could just have it, do things. But I don't like that, because then it's like A is an integer which equals 1, and then A equals 2, and then you could have B equals 3, and it's like, wait, you know what I mean? Why? Nobody would ever want to actually statically declare their types, which I guess is fine. It's just confusing, like what's actually happening? What is actually happening here? Like, is it a reassignment of a type, or is it a type inference? I want these two cases to be distinguishable, at least at a glance. Snarlferb says, oh right. It's a good idea though. A equals 1 could still be assignment if A is unbound like this. Or if you're saying like the literal equals and we don't use the reassignment, because you did just write the equals. If we just use the equals as like A equals 3, then this would be a binary infix operator. So this would become an AST, which is like a binary operator with an equals, right? And then we'd have like A and 3, if that tracks. And it would be hard to distinguish a binary operator equals from an actual expression because we don't have any expression delimiters, so it wouldn't really allow this to be used for conditionals anymore. But yeah, I would love to use reassignment just by itself, but it seems like it's too implicit, you know what I mean? But we absolutely could. We have this right here, which is literally exactly what we need, right? Just an unknown variable name that's being assigned to. In any case, we can now do this a little bit differently. We're going to have the current token. We're going to have the token length. We're going to have n. Guess we could have that on one line. It's 78, and it's not bad. Look at us. So now we have Lex Advance, which can use and state. Lico says, yeah, I see what you mean. Also, operator overloading might be confusing. It might be confusing. I don't think we're going to have overloading, though, so it's not going to be an issue for us. You know what I mean? Because we're going to have, like, user-defined operators allowed, but we're not going to have operator overloads. Like, you're not going to be able to redefine plus. But you are going to be, like, to be able to do something like defop plus, right? Which returns an integer and takes in a, which is an integer. And you could say, like, this is plus 2, or whatever. And then you could say, oh, this is a plus 2. And we'll have stuff like this, and then you can use it like, oh, 8 plus 2. I guess it would need a binary operator. So we would do like something like b integer. A plus b plus 2. Right? Then you could have like 8 plus 2 and 6. And I don't know what this would be, but it would take 8 and say that's A, 6 and say that's B, and etc. So we're going to have like binary operators that are able to be user-defined, but you're still not going to be able to redefine an overload plus 2 now that it's an operator and make it like, oh, but this one returns a float or a byte or something like that. The idea is unique operators, and when we get to like different sized integers, we're going to have some casting, I believe. But again, we're not there. That's very far ahead in the future. Where was I? Parsing state. So we create our token. We could also have like initialize token initialize, but we don't really need to go that far yet, I don't think. So we create our parsing state, and then we should use this parsing state everywhere we can. Like that. And this will clean up a lot of our code to be not so cumbersome. Remember when I wrote the expect macro and I was like, this is bad. This is why. It's because I should have had the parsing state encapsulated into its own structure, because all of these values and arguments are actually grouped together and passed around all as one thing. Eternal Wild Fox says, implementing if statement in the runtime. Wish me luck, now I have to re-index the loop. Uh-oh. Snarlfurb says, good luck. Eternal Wild Fox says, thanks. Awesome. Absolutely, good luck, Eternal Wild Fox. I don't know if you need it. You work so fast, it's like you're probably going to be done with it by the time I've written a to-do comment. But it's all good. Lico says, I meant the equals behaving differently in different scenarios. Ah. Yeah, that would be less operator overloading and more just like an ambiguous expression. Because this would be indistinguishable, I should say, from like something like this, would it not? Or what about this? You know what I mean? Something like this. Because this should be a binary operator, which is a comparison, right? Should be a comparison operator. But then if you did like a equals 4, see, this would be confusing, right? So this is a comparison. This would be a type inferred reassignment. I guess a reassignment of a typed variable wouldn't be allowed. So we'd have to do like b equals 69. It's confusing. Because is this the return value of the if? Or is it a declaration of a new variable? There's no way for us to know unless we added some new syntax or something in here, right? It's because you can't have ambiguous cases or expressions, I should say. Okay, state. State. There we go. State. Look at that. That was beautiful. Gotta love Emacs. Okay, state. Okay. State. We still haven't fixed this one, but we're going to. State. Sure, like that. Is there a state in here? There is, right at the end. Pretty sure we moved it, too. Yeah, so now working precedence and state goes here. That one makes much more sense. Alrighty, I think we've done it. So now in define binary operator, not that. Parse binary inference operator. You can see that this can simply be replaced with state. You can even move it up and change it a little. Oop, did I see? Yeah, we didn't actually change anything here till now. So this is a copy. So we're going to use parsing state. Copy. Parse state create. No, copy our current state, please. State copy current. I guess it's a local now. And then this is going to be state copy dot length. I see. So this won't actually work. Chat. You didn't warn me, chat. See, this won't actually work because we just use the same ones. We'd have to create copies. So this parse state copy will not work, but parse state create will be just fine. Excuse me? Parse state create, no, copy. And the issue is that we actually need new variables within the parsing state. So like all of these, we need new, but we need copies. Right? Oh no, this is, yeah, because we just need new pointers, new actual values. First time chat from a new viewer, Kingman05, how's it going? What compiler are we writing? One for this language that I made up. You can see it in like episode 1. And now we have pointers, as you can see. We have pointers with pointer dereferencing. We have functions which are first-class citizens and can be passed as solutions as parameters to other functions. So you see this 69 function gets passed as int to this foo, and int is an integer function, integer returning function with no parameters. So then we can call int with no arguments, and it'll return 69 because that's what we passed here. So yeah, that's our little language. That's our compiler. Yeah. So we need to do state current, state length, and state end. Then what we can do is say state copy is equal to parse state create on current copy, length copy, and copy. These are all going to be address of. Then we can use that state and effectively we want to update. So we're going to write that as well. I'm going to say parse state update. We're just going to have all new actual values. This makes sense. And then we're going to say, yep, update all the pointers in it to the new values. This is going to require the parsing state that we can modify. This is getting a little too long, so we're going to do the classic. But yeah, Kingman, hopefully that answers your question. We came up with this new language, and we're working on it, but it's there. It's got a lot of features so far. We got pointers, we got functions as arguments, which is actually really difficult. We're doing good. And instead of out, this is going to be state. I guess this returns a void, because we just need to update the state. Look at us. Okay, so now we can say parse state update our current state, and then we'll also have update from. This will be parsing state, new state. State with new values. No, we'll just call it new state. Something like that. Okay. Awesome. Nearly. There we go. And then 3 stars. So we're basically saying every value at these pointers means these pointers should now point to that value. Cool. So now we can say update from, and we'd like to update state to our copies, which is our state copy. Oh, form. And I guess this doesn't need to be a pointer. Perfect. Perfect. So now we can update our state just like that. Kingman says, how do you do that multi-line in Vim? Is that a plugin? Hey, this is not Vim. I tricked you. Oh, I tricked you. No, not really. I'm just messing. This is GNU Emacs. So that is actually Kingman cries. The cry emoji. I tricked you. Oh. No, but in all seriousness, it's in GNU Emacs, I think it's called multiple cursors.l. It's really popular. Multiple cursors.l. If you look that up, you can also just get package install. Is it MC? Nah, it's multiple cursor. I wonder if it's not in package install. Kingman says, I'm too loyal to Vim. That's good. I would definitely try Vim out if it wasn't so such a heavy ecosystem. And I know coming from Emacs, that's really funny. But Vim just feels like everything is so foreign and so different. It's like, I don't know how any of this works and I'm scared, so I stay away from it. But we are going to write a plugin, a syntax highlighting and indenting plugin for our language, for Vim. So don't worry, we'll support you. Our language will support you. We'll have editor support for Vim. And we already do for Emacs, as you can see by my syntax highlighting here. So now parse binary infix operator. Yeah, we'll do this. I think that makes sense. And it kind of makes sense that working result would come before result. I know this doesn't matter, but it is, I am picky. I should fix that. Something's wrong with parse binary infix operator when I call it. It's the fact that that's in the wrong order. Ah. Can I do Control-Alt-T? Oop, wrong way. Can I do it backwards? Oh, that was dope. Did you see that Emacsness? RPWH says, I'm still trying to get used to Vim motions. See, I'm fine with the motion. HJKL is totally natural. It's similar to Control-F, B, N, and P in Emacs, right? Nothing's too complicated. As far as the motions, I can't move this efficiently in Vim, obviously. But I can still go up, I can go down, I can get the cursor where I need it, you know what I mean? It's just that, like, actually writing text is hard. You just go into insert mode and then go out of insert mode if you want to do certain commands, but you don't have to go out of insert mode to do other... I get too confused with the modes. The mode's real... It just... my brain doesn't work with it. Neg Vorsis says, I like Helix. Nice. I've heard good things about Helix. That's a text editor that I believe is open source on GitHub. But RPWH, Vim motions are very unnatural. I just used to play on a broken laptop as a kid and like broken keyboards. So I wouldn't, the arrow keys were usually broken on the keyboards I was using. So I'd have the arrow keys mapped to like M, left, right, and question mark. And I would make those the arrow keys so that I could play games on the internet as a kid. I think I used AutoHotkey or like Tamper Script or Script Monkey, whatever it is. First time chat from a new viewer, Wagafa. I use something similar to Helix, I think, Kakune. Ooh, I've heard about Kakune. Is that one open source as well? I think that one looks beautiful. Kakune is just, it's nice. It's like that's for a writer. RPWH says, I actually unbound the arrow keys so I would stop relying on them. That's awesome. That's a great idea. Yeah, you should never use arrow keys, pretty much ever. So. Wait, what? So we have status, context, stack, state. Oh, there's no comma. That's all. I was like, why isn't this fine? So we've fixed all our parse binary infix operator. There's not too many, which makes me want to change this working result the other way around, but it's fine. You know what? We're just going to do it. It's not fine. This is needed. I promise. Because we can just Control-Alt-T and they swap, so it's not like it's the end of the world. Oh, we didn't catch that right. That's it. That's literally it. We gotta do something about that. Perfect. Good enough for me. Alrighty. Alrighty. RPWH. That is really cool that you're getting into Vim, though. It can be so intimidating to get into a text editor that isn't like just a normal text editor where like use the arrow keys to move the cursor. Click a button to type that key, that symbol that's on the key. It's like, oh, now there's commands and there's like plugins and things I have to remember, and it's so scary. It's terrifying. It's like I feel like a fish out of water. Okay, what were we working on? The parser stack. Did we do that? Yeah, see, there's still a lot of issues. So let's look at, like, can I find error? Next. No? I know there's something here. Code actions, is that what it is? No code actions here. See, I can never remember the command. Server menu, events buffer, standard error buffer. That may be it. That's not it. That's the standard error of the actual... Also, why? Where's this buffer? Can't close it? Yeah, there we go. It just doesn't exist. The buffer it doesn't exist. Amazing. I guess it kills it when you close it. Hopefully I didn't kill a buffer I needed, like parser.c. Oh wait, I did. It doesn't matter. It does not matter. Wagafa, how do you like Kakune? Is it a... What's the paradigm of it? Is it like for power users? Is it for narrative writers? What's the idea there? Also, RPWH, I'm curious to hear, like, what got you into, like, getting used to Vim? Like, what makes you motivated to try it instead of using, like, Visual Studio or any other text editor? RPWH says, yeah, for sure. Just very impressive seeing people proficient at using Vim and Emacs work. That's awesome. I get it. Wagafa says, it's Vim reversed. Lamau. What does that mean? Miv. So we do a custom state copy here. So we could do parse state. And we'd basically like to create, but we don't want to use these. See, how did we do this copy before? See, when we parse state create, the issue is that we just use the tokens directly, as you can see. So we'd actually like to parse state update. But that means we actually need to create a new state with all these pointers and everything. So we still have to do it like this. We can just use this little state copy helper. So in the other state copy scenario, this is, yeah, very much so wrong. Wrongo. We need to create value copies of each of the actual copies. You know what? I wish I could actually read, because this right here is exactly what I just talked about, where it copies the values. And then this right here is where it's using these new pointers of the copies. But I can't read, so I just figured like, oh, I'm using the originals. What am I doing here? Hoarder. Oh, kill me now. Address. I have the power of the Lord and anime on my side. Wagafa says, Kakauna, you have constant feedback on your keystrokes, basically. In Vim, you have to remember stuff like 3DD would delete 3 lines. Exactly. But you don't see what lines would be selected and deleted while pressing the keys. Exactly. Alright, so Kakauna lets you under... it's not so confusing. Alrighty. Sorry about that. Handling some phone stuff. Wagafa says, yeah. Oh, but in Kakauna, you press X, select a line, 3J, go down 3 lines, and then you can press D. I find Kakauna, and I think Helix has the same mindset, easier to work in than Vim, but it's somewhat early in development, so there are issues. That makes sense. So that's a lot like Emacs with the region, and selecting the region and being able to do things to it. Like, you can indent the region, or evaluate the region, or things like that. Or you can delete the region, or you can, not delete the region. Copy and paste, stuff like that. So it sounds like Kakauna has a really good workflow, or at least one that I think I could wrap my head around. So we're going to say parse state update from state copy. Look at that beautifulness. RPWH says, I like that NeoVim has good LSP support. That's very important. That's true. Kingman says you can use Shift V and select lines and then press D to delete the lines. Is that in Vim, I'm presuming? But yeah, good LSP support is very important. As you can see, like, having this down here is very much helpful. This is like the function signature, so you can see, oh, and the proper argument is highlighted, as you can see. And things like, oh, parse state update from, here are the parameters. Also, you can't hover over this one, it breaks sometimes, but it's fine. See? But it is pretty cool. Egglet, look at that. Ooh, Eternal Wild Fox says, check Discord. Let's do it. Hey, what do we got? If statement working. You already have your interpreter up and running? Oh my god. Oh my god. That's incredible. In 2 files. Look at that. Look at this crazy man. In 2 files. That's awesome. If 2 is greater than 1, print 1. 1. If 1 is greater than 1, print 1. Nada. Ooh. That's so exciting. That's really cool. You're running your programs. You're writing programs in your own language and running them. That's pretty dope. Pretty dope, Eternal Wild Fox. Thank you for sharing. That's so awesome. We're gonna party. Woohoo! Yeah, yeet! If you have an empty soda can, you gotta yeet that. It's out of here. Eternal Wild Fox says, the if does not have else. That's okay. You can implement else, but manually, really. So it's technically Turing complete, I'm sure. But Eternal Wild Fox says, but it is nice. It is absolutely nice. It's nicer than nice. It's very nice. It's so sweet. This wide taskbar, it helps you complete all these amazing programs in the old, like, so fast. Just fast as the Flash, you know what I mean? It's amazing. RPWH says, I also like how rich the Vim ecosystem is, and lots of visual customization. That's true. That was a large part of why I liked Emacs. I was like, wait, you can change faces, like, as you're going? So you can just, like, oh, change, the font lock for types. If you don't want them blue, you can just go, oh, customize it. Yeah, I actually want it to be anything. And you can just change all these during runtime. It's so cool. In any case, I think we are starting to actually complete our little conversion from all these separate parameters to a parser state. Oop, here's some errors. So you can see that we now have the copy thing going on. So we'll do parsing state copy, which equals parse state create from current copy, length copy, and end copy. Perfect. RPWH says, my Vim basically looks like VS Code at this point, minus electron bloat. Lamau. That's pretty awesome. Yeah, I get told this looks like Vim a lot, so I'm not sure why, because Vim, as far as I know, looks like this. Right? This is Vim? No? I'm not sure why people tell me it looks like Vim. Maybe it's just the bright mode line at the bottom. Maybe that's why people think. But it's just my my little mode line. In any case, NeoVim is probably different though. It probably has much more user-friendly customization of visuals. So we can use current copy beginning. We can next advance into state copy. Type symbol would be current copy beginning, length copy. See, we could use state current just to stay consistent, but it doesn't really matter. You know what I mean? State copy current. Same here. We could have state copy.length. What's your issue? Oh, we probably have to pull up. See, we have to dereference this, but not this because the dereference actually happens right here. How beautiful is that? So now with our state copy, where else is it used? Guess we use this. Okie doke. Look at that. So, looking pretty good. What's the issue here? Oh, expect takes just state. Why'd we go through and change all these to state? What were we thinking? I don't know. We'll never know. We'll never know why my craziness does what it does. RPWH, ooh, sent a picture. That's the only picture, by the way, I will open on stream without looking at it first. Because I trust RPWH. He's a supporter of the stream. Don't try and send dick pics, please. I will not open them. I just trust this one person. Oh, this is really nice. This is like very clean and professional. I like your little speed bar. What is this called? A tree view? In Emacs, I think we have speed bar. Oh, it opened on another, in another frame. That's Pog. Look at that. So it opened in its own frame instead of its own window. So this opened full screen on my other monitor. That's why I had to move it here. Pretty dope. And you can see it'll, like it keeps track of which one you're in. Lol. But yeah, yours looks much better. I think there's also projectile. I don't think I have it anymore. I used to use projectile a lot. Yeah. RPWH says, yeah, I can't remember the name of the specific plugin, but it's just a file tree. Nice. Those are really handy, but Emacs's buffers are just so it's so ingrained into me now. Like I just have a list of everything open and I can just find everything I've opened there. And if not, I can search from the current file relatively. It's so cool. Also, I missed a follow, but tomorrow, thank you for the follow 21 minutes ago, if you're still here. Shout out to you. Nexovex says, hello, Lens. Nice language you got there. You just told that one person you trust them. Oh, true. RPWH knows that, though. If he wants to send a dick pic, he can. He's allowed. No, I'm kidding. Please don't. Nexovex replies to RPWH, nice background. Nice. RPWH says, yeah, I like having the buffers visualized as tabs, more similar to what I'm used to. Yeah, most people don't like the invisible buffer list, but for me, it's actually really helpful. It makes a lot of sense, at least, for how I work, which is stay in one file forever. So with the state, I think we're dealing with everything properly now. Oop, that's not what I meant to do. Well, we're going upwards now. Is that a bug? No, that's Stradoop deprecation. I'm just looking at the left fringe to the left of the numbers to see if anything is sus. Oop. Nope, another Stradoop deprecation, another Stradoop deprecation. So do you know how long it took me to get my line numbers where they don't move, like go in and out as you go up and down the file? That shit was so annoying. Nexovex says, can't you have a buffer that visualizes the tabs? Lol. Kappa. Yeah, see? Look at this. Isn't this amazing? Simple to understand, right? Not confusing at all. That's iBuffer. And then here's the even better part about it. You can mark. You can say, yeah, I just want to close this one and this one. And then, oop, don't delete that. Close them. And then you can say, yep, kill them bad boys. Craziness. A buffer that visualizes a buffer of a buffer. How many buffers can a woodchuck chuck? Is that what it is? How many buffers can a woodchuck chuck? Okay, I think we've done it. And luckily it's completely broken, so this is perfect. No, this is just because we have our function definitions inside the header file. Begin lexer. Can we go to end lexer? Perfect. Can we go past these a little bit? Parse state create. Parse context. Parse stack. Yeah, this is a good spot. And now just get rid of all the ODR violations. 88's too long. We're gonna say token length. That's better. Deal with that. I can deal with that. Can I deal with this? That's a little long. About token and length. That's not bad. Woodchuck can chuck at least 255 buffers. It's a 1-byte chuck. Lamau. Or a 1-byte buffer? Is it a 1-byte woodchuck or a 1-byte, ooh. Ooh. We have parsing state, parsing stat, parsing context. I noticed that stat create was just kind of lumped in here. Okay, that's better. A little bit better. Okay. No more ODR. And look at us. Everything still works, chat. We didn't break everything. Let's make sure we still, like, generate code and stuff. Yeah, look. We have code. We can call factorial. And if we can write a little command using GNU assembler to assemble an object file, using GNU linker to link an executable, and from that object file, and then we can run that executable. Shell command failed with code 120, which is exactly factorial of 5. Factorial of 4 is 24, so we can do a recompile. See, now we have factorial of 4. Look at that. Factorial of 4. And in the assembly factorial of 4, we can do the same thing. And shell command failed with code 24. So now here you can see the answer to fact of 4, factorial of 4. And here's the factorial of 5, somewhere where it says 120. There it is. Nexovex says it's a 1-byte buffer of buffers. Ooh. Okay. Looking pretty good. Everything works. Let's make our get the commit. That took much longer than I thought it would. But to be fair, we're like adding a new object into the mix, so of course it would change the semantics quite a bit. Okay. Looking like the entire parsing parser.c is going to be committed. I'm pretty sure there's a comment in here that we shouldn't commit, but I don't know where it is and I don't want to track it down. Parser.c, you're in. Not urine, you're in. Also parser.h, could you please not recursively include yourself? That really doesn't help me. Ever. God. That's the language server integration that I don't like. I still haven't figured out how to turn it off. So now parser.h, we can get both of those. Type checker, we can add these little fixes and warnings. Doesn't really matter. We changed the factorial just to change it at the end there, prove that our compiler is working. So that's not needed. And yeah. There we go. So now we will say parser. Parser what? Parser. Use parsing state to keep track of parser's state. What do you know? I didn't mean to. I hate when I accidentally save this file. There we go. Okay, so instead of passing the 3 struct parameters around manually, we grouped them together so we no longer, so we can pass the one object around. Perfect. I think that's good enough for me. Instead of all 3 every single time. Good enough for me. Push it, push it. That's right. We're not keeping it local at all. We're pushing as soon as we make that. So look at us. We did it. We did it. We did it. How long did it take us? It took us over an hour. I'm so sorry, chat. You just watched me do this for over an hour. Oof. I mean, I guess I just didn't plan for me being built different, you know? Okay, let's do this. Implement division and bit shifting binary operators. So in CodeGen, or let's say in parsing, you can see that we have all these binary operators defined, and one of them is the divide operator right here, right? Which is horrible. And this is horrible because we don't actually deal with it in CodeGen properly. It's empty. And the reason for that is because this this little div instruction sucks. Like, seriously sucks. And let's take a look. Negvorsa says, my struct copy equals original. Isn't this copy all fields bits by bits? Yes. You are correct. You are absolutely correct. It's not relevant, though. I understand what you're getting at. State copy. I know. Doesn't look right. I promise. We need to. Because you know what the issue is? The values in the structure are pointers. So we're trying to create new pointers. We don't need new values. So we can't copy the values. They're just pointers. We need to copy the values from the pointers that we dereference. See, there's a dereference here and a dereference here. So we dereference our state and get our end pointer, and then we dereference that to get our actual end value. And the reason we do this is to get a new pointer, see, this address of. This is the important part that we need. You know what I mean? But it's kind of confusing to do this, and it's not possible, so we have to do it this way. But we need 3 new value pointers for every single member value in the parsing state. So I get what you're getting at. We can just copy all fields bit by bit, and that's not what we're doing here. Now let's move on to division. I like how you're thinking, Negvorsa. I like how you're thinking, though. So we have signed divide, and as you can see, the result is always stored in RAX, no matter what. Isn't that useful, chat? Isn't that just great? It's not great. So what we're going to have to do is save and restore these every time. So number 1, we're going to say division. Isn't this horrible, chat? This is why division should be avoided at all costs. It's horrifying. Right? So we're going to do division. Did we already do a binary operator printout? We probably did. Yeah, we did. We did a thing already. We don't need it. So all we have to do is say, yeah, save these things. We're going to push racks. Right? We're going to push RDX. And then we're going to pop them. Okay. So now we won't mess up our other code using these registers just by generating this code. So now let's think about how the instruction actually works. We do a divide racks by whatever we have. So now the idea would be to load racks with left-hand side of division. I'm not going to say divisor or dividend. I'm not going to confuse everybody using those terrible words. I'm going to say load racks with left-hand side of division operator. Perfect. So the interesting thing with this is we're going to have to generate the left-hand side expression, which I think we've already done. See, the left-hand side expression is already done, and so is the right-hand side. So expression children result register. Yeah. So shouldn't we deallocate? I guess we have different deallocations based on if they stomp or not. Okay. I know I'm talking a lot. So now we have to, and then we're going to call div with right-hand side division operator. And then we're going to move return value from racks into wherever it actually belongs. Perfect, right? So we would like to write some code that says move something into racks. What are we moving into racks, though? This would be a register name, and this would be the register name of our expression children, which is the left-hand side of our binary operator expression, and that would be the results register. I don't think that's too insane. Make sure to put new lines. So we move the left-hand side result into racks. Check if left-hand side is already in racks or not. Check that right-hand side. Basically, if right-hand side is in racks, we must save racks first. This is why you don't do division, by the way, in programs when they tell you division is slow. This is why. Because all the other ones are literally one instruction. This is not one instruction. Pushing and popping in reverse order. Ooh, you right. You right. Thanks, Negvorsa. You're the best. We would have got that eventually, but it probably would have been tough. Negvorsa, thank you. This is why I always appreciate everything you say. Even if it's like not the solution, it's an actual, like, you're thinking, you're using your brain. You're not just going, rotate the thing, hit the button, the thing works. You're like, wait, I think this may actually work like this. And it's so awesome how you describe yourself, Negvorsa. I like how nice you are. RPWH says, I think I have a keyboard addiction. You think? I know, buddy. You bought, what? 2 custom mechanical keyboards right next to each other? I mean, they're both amazing. I'm not going to complain. I love looking at them. Like, I still just scroll up in the Discord from time to time and go, ooh, oh, oh. You know what I mean? I am absolutely a keyboard addict as well. But I just am more poor. I have a keyboard from like 8 years ago still. It's like a Cooler Master Storm or something. It's awful. But it's Cherry MX, so they're still here. They're still kicking. And the keycaps are not like faded. They're not all scratched off, so that's a plus. Okay, so we have some to-dos here. And then we want to call div with some string, which is the register name of the expression children. Result register. Whoops. Oh, and R. So effectively, we're saying divide this left-hand side by this right-hand side and store the value in the result register. Do we have a result register allocated for ourselves? We don't. So we actually have to allocate our result register. So we would like to allocate a result register for our current divide expression and say we would like to move from racks into whatever this register name is of the expression. Result register. Not bad. And then obviously we can register deallocate somewhere else. Oh, these are awesome. Is this Elvish ortholinear? Is this Tolkien Elvish? That's actually pretty dope. First time chat from a viewer, Vvax3794. How's it going? Hey, hey. What's up, Vvax? How is it going? These, by the way, RPWH, these look fantastic. These are going to be sweet on that lily. On these boards. Ooh. Oh, and they're going to match your other one? Oh, it's going to be dope. This is amazing. I really like these little accented arrow keys. They are going to be great for like layer switch buttons, right? This is so cool. Very cool keycaps. Vvax3794 says, going good, just working on a Rust project. Nice. What are you working on? What's the project? It still works. So now we actually have to test a division. We'll try it. 16/4. Move return value from racks into wherever it actually belongs. Again, to do. Checkif result register is racks. Because then we don't have to do it. Okay, so now I'd like to go to code.s and change my example to my div test. And let's see what we get. We get a binary operator with 16 and 4. That looks pretty self-explanatory. And what do we get here? We forgot a new line is what we get here. That's on us. That's better. Vvax says Discord API wrapper. Nice, you're making a crate. Vvax says trying to figure out event deserialization right now. I know how I want the data to look when parsed, just trying to think of the nicest way to get from the JSON to that. Ooh. I always love data manipulation, that's fun. Move 16 into racks, move 4 into R10, move racks into racks. See, here's that thing, that case that we had to account for that we don't. And we divide by R10. So racks should be 16, this should be R10. We move racks into R11, and then we move R11 into racks. We have some inefficiencies, yes. Failed with code 149 and no output. So I would venture to say that it didn't work. Push RDX, pop RDX, push racks, pop racks, push RBP, pop RBP, okay. So what's going on? Also, we can just write pop. They're 64-bit registers. Okay, so if left-hand side is in racks, so basically, don't I have something for this already? Thought I compare registers somewhere. I don't remember. Vvax asks, what are you working on at the moment? This is a compiler that we have written completely for fun and completely from scratch. So there's no third-party libraries. This is in pure C. And effectively, it's just I don't have a plan. I'm just making a compiler. And it's going really well. It's going really well. So we have, for example, if we take a look at examples, here's a factorial implementation. A terrible factorial implementation, but one nonetheless, in our language. Vvax asks, it outputs assembly? Yes, it does. We output assembly right now so that we can use GNU as and the whole open source and free GNU toolchain. Yeah, this is the output it outputs, I should say. This is the code and the assembly it outputs from this test. So 16/4 becomes bleh. We just haven't done division, but we already have like factorial, we already have functions, and we already have first class functions. So we can actually check out the downwards funarg problem, which we have already solved. And currently we have some syntax, some placeholder syntax, where we have to say the function signature twice, one for the expression and one for the declaration. But for now, this is what our functions look like. And as you can see, you can pass 69, which is an integer returning function, which is assigned to this lambda, which returns 69. We can pass that as a variable into this function foo, and then we can actually call integer the passed function. And this will return 69 from this function, which means that this whole program returns 69. How about that? But yeah, so we have pointers as well. We have pointers working, so you can create an integer and create a pointer to that integer and assign it using the address of operator. Just like in C, you can dereference the pointer and write a value to it. So this will say A is now equal to 69, even though we never reassigned A, like that. Does that make sense? That's where we're at. And yes, it outputs assembly, which is what we're currently working on because we'd never code gen the divisions because we just haven't done division, and division sucks to code gen, in case you didn't know. Vivac says, that's really cool. Thank you. I'm glad you like it. I've been out here getting called simple. I'm glad you find it really cool. But yeah, the division sucks, in case you didn't know. Division is a real problem. So we're gonna solve that, and that's what we're solving right now. But yeah, we basically just have to divide. Vivac says, only compiler I have made compiled to brainfuck. Nice. That's pretty hard, honestly. Arusia says, to be honest, multiplication sucks too. It sucks way less. Multiplication is destructive, but it just means that you can use one of your operand registers as a result register. It's not that hard. It's easy. It's still one instruction. It's just one thing. Multiplying is hard, but it's not as hard. Division is like, oh yeah, the quotient is always in racks, so good luck. Arusia says, yeah, I agree, div is worse. I don't understand why we have to use a specific destination register. Every other instruction, you can use any register as a destination, but no, div, it's gotta be that. It's gotta be that type of thing. Still failed with code 149, so we're still doing something very wrong. Let me make sure I'm not doing like an idiv problem. Yeah, see, it's still the same. So R10 should have 4 in it, 16. So rack should have 16 in it. And when we divide R10, that should be 16 divided by 4. And that should be stored in racks, which gets moved to R11. We pop back into racks, whatever it was before, which is 16, because we had to update it to 16. Again, lots of inefficiencies, gotta love it. But in any case, we are not returning the proper thing, even though it seems like we should. Does anybody know why this doesn't work? Does anybody know? This assembly. So we push, pop, racks, RDX, RDX, rack. So that's the proper order. So what does this do? Move result of division into function return value. Store racks, RDX, division result registers. Store division result in division results register. Divide. Move left-hand side into racks. This will be save racks, RDX, division result registers. In new division result register. Okay. First time chat from new viewer, Sir Aid. Thank you for coming to my aid. Says, I think you might have to zero extend / sign extend something. IIRC, haven't done this in a while. That's if I remember correctly. I think the instruction for that was CDQ or something like that. Well, we got nothing else to go on, so thank you, Sir Aid, for lending us your aid, and we will try and find CDQ. I don't see CDQ here. Convert word to quad word. So doubles the size of the operand register. So do we have to do a div q? Is that what you're saying? No such instruction. These aren't comments. Sorry. Gotta love comment syntaxes of assembler. See, we still fail with code 149, even though we do div q. So I don't think we need to, like, do that, because when we divide RDX, oh, okay, I get it now. So we're dividing RDX racks by RM64. So RDX actually contains our higher bits. Okay, I'm getting it now. I get it now. So the issue, see, we save RDX because I thought RDX was just used as the remainder, because you get the remainder in a Euclidean division. But the actual issue lies in the fact that RDX is used in the division itself as an input, which I didn't realize. I've only dealt with 8-bit divide, apparently. Well, now that makes sense. So basically, RDX is sign extended, or RDX is the high bits of what we need. So we just need to clear out RDX. Do we do that? I think XOR is the quickest way to do that. Does anybody remember? Zero RDX to not interfere with division result. RDX is treated as the 8 high bytes of a 16-byte number stored in RDX racks. Perfect. So now, if we look at this code, okay, yep, new lines, buddy. First time? First time. There we go. So now we have the integer 4, and we say push racks in RDX, zero out RDX, move the left-hand side into racks, which again we have to check if it's racks, and then divide, move racks into R11, restore your result registers, move R11 into racks because the function main has its result register of racks, and then return. So now, hey, it worked. We got the answer, failed with code 4. Or it was just a chance. So let's do something else. Let's do 24 by 4. That should be 6. And let's think about it. Ooh, it worked. Chat. We're doing it. We're doing it, chat. Hey. Vivac says, remind me to never touch assembly. Is XOR really the fastest way to zero something in assembly? That feels wrong, but I know literally nothing. XOR to clear a register is more efficient because it also avoids false dependencies, as far as I know. Sir Aid, you're absolutely correct. That's the complicated reason. The simple reason is, like, it's a CPU, so assembly isn't faster or slower. But hardware CPUs, they aren't built to, like, write 0 into a register. So moving 0 into a register is actually, like, it's complicated to load an immediate value into a CPU. So the idea is that effectively, instead of having to load an immediate and then store that in a register, you can just operate a register, do an ALU operation. So the CPU has an arithmetic logic unit, right? Which is an ALU, and one of these logic things it can do, right, is XOR. I know this is terrible, I'm sorry. So the ALU basically has different operations that it can do. So the arithmetic and logic unit is inside each CPU core, and it can basically do different operations on bits, and XOR is one of them. So XORing a single register is like very fast. And it also, like Sir Aid says, the complicated reason, it avoids false dependencies, so we don't need anything other than what's actually right here. But we are doing it. We are officially cogenning division in its horrible horribleness of x86-64 division. Look at us. We're professionals. Division. Should probably write what each one does, no? Otherwise it might be a search and replace. Not a search and replace, but just searching the file. It wouldn't come up at all. Plus addition. Equality. Equality. We got less than, which is also known as below. Greater than, which is also known as above. I think that's good for binary operators, for now at least. Oh, Wagatha pointing out a misspelling. I wrote subtraction instead of subtraction, Lamau. I gotta slow down. I'm typing too fast. At least I spelled addition right. Neg Forces says ARM has a register that always be 0. Does it really? I want to learn ARM assembly so bad, but there's no... I feel like there's not any resources I can find on it. They're all like, oh yeah, here's this 34 different instructions, and here's how you can use them. Anyway, good luck. There's no examples like, here's how to use an emulator to actually run the assembly that you write, right? Nobody goes through that. So I'm a little sketch with QEMU and like, do I have to run an ARM OS to deal with all that? Sir Aid says RISC-V has that too. R0 is always 0. Do you know why that is? It's basically because 0 is a P&O, is all you need to prove numbers. It's a P&O theorem, effectively. If you start with 0 as being a number, then you can define every number based on that 0 number, which is interesting. So we do it. We can now divide. I think there was something we wanted to write. Oh, also bit shifting binary operators. Do we have bit shifting actual instructions? So bit shifting. So do we have like shift right? I've honestly not... Shift right mask registers. Yeah, shift. So we do have shift right. Nice. It's been a while. So we have shift left and shift right. What is sal and sar? The destination operand can be a register or memory location. The count operand can be an immediate value or the CL register. It can only be one register, Lamau. The count is masked to 5 bits, so not even an 8-bit register. It's a 5-bit. Or 6 bits in 64 mode. Oh Christ. Sir Aid says SAL equals arithmetic shift left. What? Sir Aid says, I think it's to initialize the other registers or something like that. I remember hearing about that, but I'm not really that familiar with RISC-V. Yeah, basically, by having 0 so accessible, it's you can have many math operations that are super efficient because comparisons are done to 0 almost all the time and stuff like that. Snarlferb says everything is like music, and thus everything is the chord shift of life. And, NAND, XOR, or not, left shift, right shift. I like that. It sounds like I'm listening to some, like, thing from the 60s. Some talk. Nexovex says, it's not the only one. There's like 4 or 5. Interesting. You say 4 or 5 shift registers? Or shift instructions? What are you talking about? What are you talking about, Sir A? Not Sir A, Nexovec. Sir A said the arithmetic shift left. What's the difference between an arithmetic shift, I see, and a logical shift? They perform the same operation. Okay. So shifting right, there are a difference between shifting and arithmetic shifting. But left, they're both the same. I get it now. Nexivec says, no, not at all. I'm talking about 0. Don't mind me. Oh no. So basically you're saying it has a bunch of uses. There's like 4, or are there 4 or 5 registers that are 0? That'd be crazy. So basically the difference between SAR and SHR can be used to perform signed or unsigned division. Interesting. Obviously only you can divide by 2, or powers of 2, but it works. The OF flag is affected only on 1-bit shifts. Well, that's annoying. For left shifts, the OF flag is set to 0 if the most significant bit of the result is the same as the CF flag. That is, the top 2 bits were the same, otherwise it is set to 1. Crazy! Nexivec says, I said nothing about registers at all. Alright, I won't mind you then. Lamau. Also, VVAX, thank you so much for the follow. Shouts outs to yous. So with shift right and shift left, it seems like we don't have to worry about it. We can just do it. So let's look at our parser and think about our binary operators. So we would like some new binary operators. Does anybody know if bit shifting happens with multiplication and division? Or plus and minus? Where does bit shifting go in the precedence tree? Does anybody know? Also, we're going to try this, but I don't know if it's going to work, so I'm sorry. But yeah, if anybody knows, Sir Aid says below plus minus. Really? So it's with comparisons? So it's less than a term? Bit shifting precedes plus minus. What does precedes mean? Above comparisons. Okay, so this is perfect. So when we bit shift left, I would think it would be like with multiplication. This doesn't make any sense. Because to me, 2 to the left 4, like, plus 3, we should do 2 to the left 4 first. Guys, right? Should we not? This should happen first. We don't want to do 2 to the left 7. Vivax says, well, it is your language. You decide. Thanks, Vivax. That's helpful. I know I can decide. It should come before multiplication even. So Nexovec, you're saying you're confused? You're actually the one confusing everybody. You're saying it should come before something. But then we were talking about precedence, which means it should be higher than. So saying below made things very confusing. Because when you said precedes, I thought you were talking about precedence, but it does not. It happens after, it happens before everything, so it precedes everything. So it should be higher than multiplication. So bit shifting happens first. Sir Aid says, if you're looking for some inspiration, you can always check the C operator precedence table. Lamal. It's true, I'm just curious what the people think. Nexovec says, has higher precedence then. That makes sense. Negvorsa says, did anyone know why C does not have rotation operator? What? Did anyone know why C does not have rotation operator? What's a rotation operator? Where like the stuff that goes out the right side when you're bit shifting goes into the left? Because it's not ever needed. Is why. I would say. Okay, so now with these two, we can say these are clearly after this, because 2 to the left 4 times 3, I think we should do 2 to the left 4 first, and then multiply by 3. I think that makes the most sense, because bit shifting should happen before this. So even if we have 3 times 2, we should have 2 to the left 4, which is like 16 or something, then 3. Sir Aid says, in C at least, bit shifts have lower precedence than plus minus, in case I wasn't clear. It's true. Thank you for letting me know. So basically, in C, if you did this, this would be like what? So this would be 7, and this would be 6. So we'd have 6 to the left 7. Is that what you're saying? Why are you unhappy? See, look, it even tells us a warning. Operator left left has lower precedence than plus. Plus will be evaluated first. I don't think that makes any sense, though. I think I would rather have 3 bit shift 4 happen. Sir Aid says 2 times 3 left 4 plus 3. Yeah. So this does this, effectively. But what I want is, I think, this. I don't see why this wouldn't happen. This is way more confusing. I don't know. It's easy to change. It's one number. Let's not deliberate too much on it. We'll put it below. We'll copy C so that people know what they're doing. Simon the Swede, hello, how's it going? It's been a while. So good to see you, Simon. What's going on? Thank you for tuning in to our stream. So this may cause issues with these, and we may have to add them in a different order. So we should have like 2 to the left 2. So what's 2 to the left 2? If we think about it. And that would be what? 8? I think that'd be 8. Okay, so 2 to the left 2. This should return 8. Should return 8. Alrighty. Also, we gotta load in mode. So now when we compile this, we're gonna say unknown symbol, left. So our problem is that our parser doesn't actually let us get 2 of these in a row. So when we parse our binary infix operator and we try and advance the lexer and then check the operator symbol if it's a binary operator, the operator symbol that we're getting is a valid operator. So if we take a look, also, these need to be dereferenced, I'm sorry. Perfect. So as you can see, we get the operator division with precedence 10, working of 0. We get the operator less than with precedence of 3. So the idea is we'd have to look ahead for operators that have multiple. So let's do that here, right? We're going to say, okay, we already got one, and we'd have to get another one, make the symbol, add on to the symbol string. See, that's really complicated. This is not a great parse. We didn't create a great system here for our binary operators. But it's like one of the first things we did, so it makes sense that it's not good. So where's the default? Is that where it is? Yes. So effectively, this is going to be temporary, but we have to have either single operator shifting operators, or we have to do some complicated lookup, or have like nested operators, which I also don't want to deal with. Hooray, bit shifting is hard. So for now, what if we did something like this? I know, and I'm sorry. Please forgive me. We'll say to do / fix me. These are very much so temporary git shifting operators. Okay. And so we're going to test if we can do something like that. And we still get invalid syntax. Blah. So if I put these in a different order, I'm curious if I will catch them first. Yeah, no. We still don't catch it. So you'd think the lexer wouldn't delimit on the bang, the exclamation point, so we wouldn't have to worry about that. See, it delimits on angle brackets, which makes it a bit of an issue. Eternal Wild Fox says, back from drinking coffee in a break. Working on bit shifting operators, nice. That's exactly what we're working on. It's a good thing you treat yourself with breaks, Eternal Wild Fox. You have a great workflow. You get a lot done. I should I should try and be more like you. I'm gonna have to go very soon, but we're gonna go as long as we can. So it seems like having it start with the same one is the issue. Still unknown symbol, huh? With exclamation point. I find that very interesting. So we don't actually look ahead and find this? What are we doing then? Where is it? Shouldn't we have like get binary operator? I thought we just looked at that error message. I don't care. So the issue we're having is for some reason our lexer doesn't like us. No, I don't know what issue we're having. So when we parse a binary infix operator, we're gonna print the node and say this is the symbol. This is what we're looking for. What do we get? So we get a symbol slash, the symbol 2, and the symbol exclamation point. So confusingly enough, exclamation point actually acts as its own thing because left is again a delimiter. So I hate this. Lexing issues, oh boy. So the problem is that we're saying that this ends a token. Because when you have just this, it's a token by itself, so we need to lex that, which means it needs to end itself. Which sounds so negative. Eternal Wild Fox says lexing is so much. It is. It's a lot of the work. So I just don't get why. So the fact that left is a delimiter means that we get this as a result. So I think we really should just stick with this then. And say operator symbol equals blah. And then we're gonna say, okay, if we get another symbol, it's gonna be a whole thing. And we're gonna have to have a state copy. Look at us. This is gonna be horrible. Are you ready for this, chat? For this horribleness? So we're gonna have copy. This horribleness is happening, chat. You cannot stop me. And then we're gonna have state copy. This is so bad. You know, this is, you should name your variables accurately, you know? Eternal Wild Fox says, lexing is so much fun, I meant to say. I see, you meant to say fun. It is fun. Just dealing with little tokens, lefts and rights, beginnings and ends. That's beautiful. Now, see what we'd like to do this for is we'd like to then lex advance using this using this thing. And then we could say, okay, make a symbol. So we're going to have to make a symbol. So operator, second operator symbol, it's going to be state copy copy. And let's just print this out and see how insane we are, or if we get an access denied or what. Because this is literally horrible. Eternal Wild Fox says, do I really want to implement the while statement now? It's a good question. So you can now see I get the symbol left and the symbol for. So we go here and we go look for the next thing. It's a for. That's not a valid thing. So now we should say this. But this is not going to be second operator symbol. This is going to be the giga operator symbol. This is going to be horrible. Joined symbols. Also, this is horrible, and I'm sorry that you have to look at this code. I'm gonna just try and get this working. Yeah, I don't like this at all. I don't like this one bit. Okay. So join symbols at 1 is going to equal our first operator symbol. I hate lexing. So we should really lex while we get an operator, is really what we should do, but it's fine. You know what, we're gonna put this as a to-do, and we'll get there, because here's the thing. We can lex differently. Yeah. So we're just gonna add a to-do here and say continually lex until operators are no longer getting got. This will require lexer knowledge of what's an operator and what isn't. Okay, in any case, let's just do a very dumb test. I'm going to use left bracket. Perfect. We're going to use left bracket, right bracket. They aren't used for anything else right now, and it doesn't matter to us. So let's try. Look at us. We now have binary operator, left bracket, 2 and 2. And it's all type checked. So all we have to do now is go in code gen and actually generate these. And again, this is going to be terrible. I'm sorry. I'm going to copy plus and minus so that it's less complicated. And we're going to just add in a fix me temporary bit shift operator. Perfect. Bit shift left. And this is the link. Eternal Wildfox says, my bytecode interpreter is around 400 lines of code, lol. I really abused the visitor pattern. To loop the AST to bytecode generation. That's awesome. Yeah, that's perfect. That's exactly what you gotta do. I don't think shift left is destructive, right? Is it? So we can give it an immediate with, we're gonna have 64-bit. Can we look at 64-bit of shiftle? I don't see 64-bit here. Can we not do 64-bit shifts? Hello? So we can do an arithmetic shift left. Eternal Wildfuck says, one day I will write one in complete C. I am sure of it. That's awesome. I can't wait to see it. So it looks like the arithmetic shifters are the only ones that have 64-bit operands. No, I think it's just missing, because shift right has RM64 with an immediate and RM64 with CL. But you see here we get all sorts of weird things because there's no R64 for shift left. I think it's just missing. I think there should be a Rex WD1. See, that's shift arithmetic left. Or shift arithmetic right, I mean. And shift arithmetic left. We'll see. We're just going to use shift left and shift right for now. Who knows? So for bit shift left, we want to shift left. And the idea is we either need an immediate or CL. Right? Is that true? So that's just the C register, RCX. So we're going to have to do some pushing and popping. Push RCX and pop RCX. And then we're going to have to move. So just giving it one operand means we use CL. Is that correct? I believe so. 64-bit mode, then count mask. Temp count, count and count mask. Temp dest is dest, while temp count does not equal 0. If instruction is left, then blah. If instruction is... What? We have two identical if instruction is the same thing. This must be right. I don't know. This doesn't make sense. And then effectively, I see, no, we're just setting different things. So this sets the carry flag based on the most significant or the least significant bit. See, I'm confused because the else is here. That's why. I'm getting it now. So then if it's that same thing, then multiply by 2. Otherwise, if it's arithmetic left, divide by 2 signed. Otherwise, divide by 2 unsigned. And then overflow bowl. Okie doke, okie doke. So we need to move our register into RCX. And this will be our right-hand side. So this is actually going to be our right-hand side result. And then the left-hand side result is what we are shifting. And I'm pretty sure it uses... Yeah, the first operand is the destination operand. So effectively, it's destructive. So this result register that we use for the left side is going to be used as our result register. So use the left-hand side result register because shift left is destructive. And we shift left into this register. Okay. Nexavex says, will it have a multiplayer? Lamau. Nexavex says, I just want to say, if any of you decide to make a game, don't make it multiplayer. Multiplayer isn't that bad. It's just server code. Dealing with clients who don't agree, right? It's the same as making a Windows server or a local server. It's not different. Eternal Wild Fox asks, what is wrong with multiplayer? Yeah, it's just server interaction, making sure clients agree. It can be tough, though. It's not easy by any means. I would never say that. But it isn't... I wouldn't say it should be avoided. So we need to solve the right-hand side. And as for shift right, it probably works the same way. So we're going to use the left-hand side result register as our result, since shift right is destructive. And we're going to have some things to do. And we're going to deallocate the right-hand side results register. Perfect. Next of X says it's cursed. Now, it's definitely not easy, but it is intimidating. Eternal Wild Fox says, I also want to learn game dev, so lol. And I think you can. Eternal Wild Fox is pretty professional. Also, there's no new lines here. How could you not tell me, chat? Okay, so we're gonna push and pop RCX. And in between there, we're gonna shift right by into some result register, which is actually going to be the left-hand side result register. Children, result. Okay. And then we're going to, first of all, move a value into RCX so that we can actually use it. And that's first, and we're going to move the right-hand side. So we're going to move the register of the right-hand side into RCX, blah, 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 restore RCX. I think that's not too insane. Also, I could probably handle both of these in one and just change shift left, shift right, but it's fine. Next of X says, I probably completely over-engineered everything. Everything has its custom format to send over network. No, that's right. Because you want to use like packed structs, get everything as small as possible to send over the network. It may be over-engineered still, but it doesn't sound like it. You are correct that you're like, oh, I have to send a bullet hit information. So then you make a bullet hit packet. You go, okay, a bullet hit packet needs what information? And then, okay, that needs the size, the speed, who shot, right? The position, the rotation, it's literally everything, right? And then you have to figure out how to send that over the network. Next of X says, so at the end there will be like 200 things I need to send over the network, and all of them need to be tested individually. 200 things seems like a lot. What's happening in your game? Maybe you need like a, maybe you need a, I don't know, like a generic packet, you know what I mean? Like have an entry packet and say like, this has a type, right? So this could have your type and then also size of payload. And then you could say, okay, so this is what I'm about to get, these packets. So next of X, you could definitely construct your own like little custom format to only have to send one type of thing with a different value inside of it. And then based on this value, you can decode the payload differently. I don't know, it's up to you. But 200 things seems like too much. 200 what? Because you have like bullet hit, or you have like player move. Are you making one for each one? You know what I mean? Like, you don't want to do stuff like that. You want to have, unless it's a very simple game. Nexovex says, JSON, just stop overloading network. Lamau. Sir Aid says, oh, so the shift operators are square brackets? Yeah, like we just talked about, we're saying these are very much so temporary bit shifting operators because we can't currently lex properly, like double operators. So we're going to have to redo the lexer before we can accept things like that. So we're going to have the regular like bit shifting operators. I like how those look. And function is just going to be an error or a challenge in lexing. So currently we're doing tests with these operators. Here we go, binary operator left. Move 2 into R11, move 2 into RBX, push RCX, move RBX into RCX, shift left R11, so shift 2 by 2, pop RCX to whatever it was before, move R11 into racks, which is whatever we shifted left into, and that's our result. So hopefully it's 4. Right? Shouldn't that be 8? It should be 8, should it not? I'm a little sus. Do I have to pass CL as like an operand? I'm confused. So let's see shift left example. It should probably say x86. We're looking at things. Destination count. So you see that would make sense, but we don't actually have an immediate count. And it says we have to store it in CX. This isn't helpful. See, assembly, they never have examples. How do I use it? They just ignore examples. They're like, yeah, no, people don't learn from examples. I understand that this is a thing. So how do we have CL here? How? So do we have to put CL? We can do that. It's not hard, it's just confusing why we'd need to do that. Operand type mismatch for blah. I hate this. Okay. It looks like in the GNU assembler, we can just have shift left and give it any argument, any register argument, which I'm mad about. So this uses AX. Is it really possible? See, this is shifting 2 times. Does anybody know? I really wish they did. NextOfX says the netcode will probably get simpler when each packet type gets its own packing function that describes how the data is laid out. Lua's lack of structs really helps with losing sanity. Yeah, that may be a problem, lack of structs. Sir Aid says, yeah, you're using AT&T assembly, which is like backwards. But this isn't backwards, my guy. So do I have to put CL first? So normally the destination operand becomes the first operand in GNU assembly. Is it not like that? CL has to be the first argument. Okay. I'll try it. See, this is what I hate about one, not only the GNU assembler, but every assembler. So the destination and source operands, they just switch around. It's so stupid. So shift right, the destination operand in GNU assembly syntax, the point of it, AT&T syntax, is that the destination comes first. But then for shifting, they're like, oh no, but the destination comes next. Has move source dest. But that's not how it works. I get it, though. I see what you're saying. I just hate this syntax because it's, one, isn't documented anywhere. Like, I think it would be simple to have, like, a table and say, like, move, destination operand, source operand. Right? I don't think this would be hard to have, or the other way around. Like, why can't assemblers just have a table like this and say, oh yeah, move has this, shift right has this, shift left has this? Because they're all so confusing. And like division, it's like, oh, is this the source operand that we're dividing by? It is. So this isn't the destination, this is the source. And the destination is fixed at AX. See, nothing makes any sense. And Intel syntax is just as bad. They just flip it back and forth all the time. I don't get it. In any case, hopefully this works. Hey, chat. We did it. we can run our executable and fail gracefully with code 8. Look at us. That's a little big. So we can now see, so shift left by this amount into this destination. So this is source destination, but division is source given to the mnemonic, which doesn't make any sense. There's just no destination because destination is always racks. Terrifying, terrifying. Sir Aid says, I'm used to Intel assembly, which is why I said AT&T assembly is backwards. Yeah, they're all just different. It's not that they're backwards compared to each other even. They are in most cases, but then it's like, oh yeah, now just access some memory for me. And it's like, oh, the different syntax in every single assembler for that is ass. Which is why I pick one assembler and tend to stick with it. But it still sucks. It still sucks. With that, hopefully, we have shift left and shift right. So shift left seems to be working. Shift right means that we should get 2 from this. Whoops. And if we take a look, that's what we got. We got code 2. It works. Next of X says, it doesn't suck. It's just as. Lamau. That's a good one. Okay, we did it. We have bit shifting and division. Woohoo. We have bit shifting and division. We did it. Chat, we did it. Isn't that beautiful? Our automatic indenting is confused. It's like, this is not an operator. Nixovex says, how do I know what uses which syntax? Right? You don't. You learn by going through what I just went through and going, everything I'm writing doesn't work. Why? And then you slowly get to the answer. But you're correct. You don't know what uses what syntax. You guess. There is these, which describe how they are laid out in memory, like in the actual opcode. Like, oh, you have the opcode, the register, and then the immediate. And that's like, oh, this is this opcode. But this doesn't really help us. This isn't an instruction in Intel syntax, and it's not an instruction in assembly syntax. It's just the actual opcode mapped to an instruction that we can understand with Sal. Sir Aid says, when in doubt, just write it in C and then disassemble that. We were very close to just going to Godbolt. I promise. It was on my mind. I'm like, should we just go to Godbolt? But it feels like cheating when you have to like go, oh, let's try this. And then you go, oh, that's how it works. And also Godbolt has this nice little box here. And I don't know why it hides everything by default. It's really annoying. This is the proper assembly. This is much better. All the debug info. You can see that effectively they do a shift left with CL and EDX. We could have seen that here. It's a little bit cheating. And it's I feel like it's like giving up. Like I give up on learning it. And I'm like, I'm just going to copy. So I try not to do that. Sir Aid says, that's what I did when I had to generate bytecode by hand. By hand? Are you kidding? Oh my god. Done. Woot woot, we did it. Alright, we've been streaming 2.5 hours, over 2.5 hours, 2 hours 45 minutes, and I think it is as good a time as any. I can't speak, I'm sorry. It's as good a time as any to say goodbye. So I will start and go into my little ad read, then we're going to have a little discourse, and then we're out. So, if you would, please go to the About section down below and join the Discord. There's a ton of people in here already. We talk, we have fun, we're all each other's friend, we share what we're working on, like RPWH with this badass keycap set, which is like Tolkien's Elvish on keycaps, which is just dope. Nexavic says, no, don't leave us, Lens. I'm sorry. I have a life. And also it's like I feel bad. I just sit in my room alone all day. I'm thinking of making a 3-dimensional SOLang, X, Y, and T, as a GIF. Wait. Yes. So Nick is talking about an SOLang, an esoteric language, where X and Y in a picture, and time. So you're going to have a picture and time as a GIF, and that's going to be how you write the esoteric language. That's Pog. So you're going to have like 4-pixel, like a 4x1 pixel GIF, and it could be like Rule 110. And you could jump through time. Oh Lord. Oh no. In any case, like this here, and end up at the same coordinate. Ooh, that's actually really cool. This is a good idea. But yeah, see, we have a ton of fun in the Discord. Share your thoughts. Come have fun. Be nice to everybody. We had Assad and Dean Cash join last night. Or at least last night for me. It may have been the morning for them. So shout out to them. Thank you to everybody for waving. I love everybody waving when people get here. It would be weird but cool. Very much so. It'd be very cool. So with the Discord down below, there is also the YouTube, which let's just go to and see if I come up. We're going to do lens_r. I've never used that search box, by the way. It doesn't work because Google gets rid of the underscore. Lamau. So you're going to have to go to YouTube, type in lens_r. No, just go to the link down below. You can check out my channel and all my previous broadcasts ever, including making this compiler, all the way from writing the very first file to now. So yeah, I recommend checking out the YouTube if you're interested in this content. There is plenty of it, and it's all there for you. Sir Aid says, I didn't even know that search box was a thing, lol. It's pretty rare, but on certain sites, Google has like a search box in a search box on the Google page. It's so cool. It can help a lot. Sir Aid says, calculating jump offsets was the worst. Oh no. Jump offsets? That scares me. But with that being said, I will point you down below to the GitHub. Actually, there's one more thing I forgot. There's the GitHub. So down below, you can go to my GitHub and actually check out anything I've made, including an OS, another programming language, a text editor with a programming language embedded in it, and this compiler that we've been working on for so long. Hey look, the readme's fixed. But yeah, so be sure to check it out, star it, fork it, make a PR like our buddy Arnow already has, and be a part of the development if you would like. We're accepting PRs. So yeah, that would be it. There is one more thing, actually. There's too many things. No, but there's one last thing before I end the video, and that is going to be the PayPal donate button in the Twitch About section. Now, even if you can only give $1, it means a lot to me. I greatly appreciate any and all donations that come in. And if you leave a message, I'll even read it on stream. So hey, you could get a little shout out. And if you leave your name, I'll even say how much you gave and say who did it. So yee. I recommend doing that. If you can't give money, don't worry about it. Or if you don't want to, all I ask is that you're positive, you hang out, and just chill. Thank you so much for tuning in, watching this compiler work. We got a lot done today. Not as much as I would have liked, but we chipped away at the list, right? It's not so large anymore. So thank you to everybody who was along for the ride. Be sure to hit that follow button. We will be live, I'm sure, again very soon. So come check out this channel for the future. We're gonna have the compiler. We're gonna work on an OS. So we're gonna do OS development. Stick around if you like OS development, low level programming. We're gonna make AI bots. We're doing it all. We're doing it all. Thank you, and I will see you next time. Bye-bye, everybody. I love you. I love you. Bye.